Hello everyone, welcome to Cyber Platter. This is a video on ISC Square CCSP exam to help you prepare for it. Today we will cover a portion of Domain 3, Cloud Platform and Infrastructure Security. So this is the agenda for today: plan, disaster recovery and business continuity. In that we will be discussing risk related to the cloud environment, business requirements, and the terminologies that we use in BCDR, that is RTO, RPO, RSL, and what is the strategy of BCDR, how to create, implement and test the BCDR plan. Okay. So first, let's understand what is Business Continuity Disaster Recovery Plan. So BCDR plan comprises of two components, that is Business Continuity Plan and Disaster Recovery Plan. The Business Continuity Plan allows a business to plan what it needs to do to ensure that its key products and services continue to be delivered in case of a disaster. Okay. Whereas the disaster recovery plan allows a business to plan what needs to be done immediately after a disaster to recover from the event. Terms like event and disaster will be very common when discussing this. So an event is an unscheduled adverse impact to the operating environment. Okay. An event is distinguished from a disaster by the duration of impact. We consider an event's impact to last 3 days or less. A disaster's impact lasts longer. An event can become a disaster. Causes of event or disaster can be from, caused by humans or natural forces, internal or external, malicious or accidental. We will discuss that in the next slide. So many of the risks that are in traditional IT environment are in cloud environment as well, and it has a little more that are specific to cloud. So the first one is natural disaster risk. This is like flood, fire, earthquake, hurricane, tornado, etc. Deliberate human risks: DDoS attack, ransomware, terrorist attack, employee strike, disgruntled employee, right? Insider risk. Accidental human risk: it can be fire, explosion, human error, like by chance deleting a file or a database. Indirect human risks: equipment failures, power outage, telecommunication outages, outages due to provider going out of business, lack of support staff, etc. Now let's see the risk related to the business continuity disaster recovery strategy. The first one is new dependencies. Your data and operations will be reliant on external parties in whole new ways after migration. Not only will you have to depend on the cloud provider to meet your organization needs, but all the downstream and upstream dependencies associated with the provider as well, including the provider's vendors, suppliers, utilities, personnel, and so on. So here we have to take into account the possibilities involving the provider's inability to meet service requirements, in addition to similar failings on part of any of the provider's requisite entities. Next one is cost and effort to maintain redundancy. Any BCDR plan requires some level of redundancy, which comes with a level of financial and operational risk. If you are operating in a hot configuration, that is active configuration, you will need to ensure that both the primary and the secondary sites are fully staffed, configured and updated at all times. Maintaining this type of configuration requires that the primary and the secondary locations remain in sync, which can be operationally challenging. Syncing primary and secondary locations is made easier with cloud infrastructures because the cloud allows near real-time syncing between regions, and you can have your data maintained in multiple regions automatically. This convenience does, however, come at a cost. The higher level of redundancy not only increases availability but also your usage fees. The next one is regulatory failure. The efficiency and ease of data distribution in the cloud enhances potential violations of regulations as users and administrators alike disseminate data in new ways. The cloud provider presents another potential point of failure for regulatory compliance as well. Even if your organization is fully compliant internally, the provider might be unable or unwilling to adhere to your policies. Regulatory failures could include insufficient protection for PII data to comply with regulatory requirements such as GDPR, GLBA, HIPAA, FERPA, or SOX, and they might also take the form of contractual inadequacies such as copyright licensing violations. The business impact analysis needs to include discussion of possible impacts from this situation. Performance hit due to location change. If an outage to one cloud data center or region forces your resources to fail over to another region, you can be faced with latency issues. Despite cloud infrastructures being developed and configured to run your workloads from multiple geographic regions, the way the internet works means that the closer you are to your data, the faster you'll be able to access it. The latency and performance that you get when failing over to a region across the country may very well be noticeable. This risk can impact the cloud customer's perception of the cloud service provider and may trickle down to affect any customers that use the cloud customer's hosted services. You can mitigate these risks by selecting a cloud provider with multiple regions available to support your geographic needs. Decreased operations during or after failover. If you experience a complete outage of your primary site and you must fully failover to your secondary site, you must be mindful of a couple of potential risks. The first one is the speed at which you recover may present a risk to your business operations. This risk is generally less of a concern for cloud environments because of rapid elasticity, but full failover and recovery is dependent upon you properly maintaining backups of data and virtual machine instances. Again, cloud can help automate much of this risk, but it is your responsibility to configure these settings according to your organization's needs. The second one is if your applications contain custom code or API calls to or from external services or IP addresses, you run the risk of not maintaining proper functionality post failover. This risk can be mitigated by ensuring primary configurations are saved and readily accessible should a BCDR event occur. Next one is data breach or inadvertent disclosure. Cloud computing magnifies the likelihood and impact of two existing risks, that is, internal, personal, and remote access. Moreover, because full legal liability for breaches of PII can't be transferred to the provider, the cloud customer must reassess the potential impact and effort of an unauthorized disclosure, especially in terms of costs resulting from data breach notification legislative mandates. Other potential adverse results from breaches that should be addressed are public disclosure of internal communication and reporting, loss of competitive advantage, negative effect on customer, supplier, and vendor goodwill, and contractual violations. Vendor lock-in or vendor lockout. We should take these risks into account for any operations migrated to the cloud. Much of the data for this part of the report is calculated during the cost-benefit analysis, and the same can be used for business impact analysis. The next one is risks related to the BCDR use cases. There are three types of use cases. The first one is primary on-prem secondary cloud service provider. If the organization maintains its own traditional IT data center for the primary production environment, BCDR plans can include the use of a cloud service provider as the backup. Negotiations with providers will have to include periodic upload bandwidth costs, frequency of backups, whether the organization will use a full incremental or differential backup schedule, the security of the data and systems at the backup data center, the ISP costs. In this methodology, the customer should determine when failover will occur. That is, the customer can decide what constitutes an emergency situation and when normal operations will cease and the backup will be utilized as the operational network. This may involve a formal declaration to include notifying the provider and will almost certainly require additional cost for the duration of this crisis event. Failover might take the form of using the cloud service as a remote network. or it might require downloading the backup data from the cloud to another physical production site for contingency operations. The negotiation between customer and provider should determine how and when that download occurs, how long it should take, and how and when data will be restored to the normal operations locations at the end of the crisis event. This cloud migration can be a complex process. So, if any organization procures a cloud provider strictly for BCDR purposes, they must ensure that their workloads are able to migrate to the cloud and operate seamlessly in a failover situation. Use of containers within the on prem solution can provide added portability and help ensure compatibility when migrated. The second use case is primary cloud service provider, and the same cloud service provider is used as the secondary site as well. One of the attractive benefits of cloud operations is the resiliency and redundancy offered by cloud data centers, especially from market leaders. Cloud providers might offer a backup solution as a feature of their service, a backup located at another data center owned by the provider in case of disaster level events. In this, the provider will have all the responsibility for determining the location and configuration of the backup and most of the responsibility for assessing and declaring disaster events. The customer may have some minimal participation in the failover process. BCDR activity, including failover, should usually be transparent to the customer in this case. Moreover, if this feature is offered as part of the normal cloud operation, it will usually be at no or little additional cost. So, this scenario generally comes with the least amount of risk. The organization must evaluate the cloud service provider to ensure multiple cloud regions exist that will support their requirements. Cloud service providers sometimes do not operate all cloud services in every region. Make sure that you select a secondary region that offers the functionality and performance that your organization needs to continue operating smoothly. The next one is primary is cloud service provider and the secondary is another cloud service provider. In this situation, regular operations are hosted by one cloud provider, but contingency operations require failover to another cloud provider. The customer may opt for this selection in order to distribute risk, enhance redundancy, or preemptively attenuate the possibility of vendor lockout or lock-in. This may be the most complicated BCDR arrangement to negotiate because it will have to involve preparations and coordination between all three parties, and roles and responsibilities must be explicitly and thoroughly delineated. Under this arrangement, both the primary cloud provider and the cloud customer will take part in emergency assessment and declaration, and failover may require joint effort. This can impede the process, especially during crisis when cooperation and clear communication is most difficult. The cloud customer will have to negotiate all the terms with both the primary and backup cloud providers. Usually, this will also be a relatively expensive methodology. The backup provider will not be a cost bundled with other features offered by the primary provider, and both failover and contingency operations will entail additional expenses. Also, data format and system port interoperability may be a significant concern. The customer may need to perform additional activity when porting data from one cloud provider to another in order for the data to be used properly at the destination. So finally, the conclusion is that no matter what your use case is, BCDR is an important topic that deserves a lot of attention and planning. A full assessment of potential risks is a prerequisite to determining an appropriate BCDR plan for your organization. The next topic is BCDR relevant cloud infrastructure characteristics. Rapid elasticity and on-demand self-service lead to flexible infrastructure that can be quickly deployed to execute an actual DR without hitting unexpected ceilings. Broad network activity reduces operational risk. Cloud infrastructure providers have resilient infrastructure, and an external BCDR provider has the potential for being experienced and capable because the provider's technical and people resources are being shared across a number of tenants. Paper use can mean that the total BCDR strategy can be a lot cheaper than alternative solutions. During normal operations, the BCDR solution is likely to have a low cost. Of course, as part of due diligence in your BCDR plan, you should validate all these points with the candidate service provider and ensure that they are documented in your SLAs. The next topic is what is the focus of BCDR? The paramount importance in BCDR planning and effort should be health and human safety, as in all security matters. With that in mind, any BCDR effort should prioritize notification and evacuation as well as protection and egress. Notification should include the organization's personnel, the public, and the regulatory and response agencies depending on who might be affected by the circumstance. Evacuation, protection, and egress methods will depend on the particular physical layout of the campus and facility. Let's see some of the aspects that are generally included in the evacuation, protection, and egress methods. So the first aspect that you should take into consideration is getting the people out, that is health and human safety. There should be no obstruction or delay of personnel leaving the facility. All doors along the emergency path should be fail safe, that is they can be opened from the inside allowing egress even if they are still secure from the outside, preventing ingress. Sufficient lighting should be considered. The next one is getting the people out safely. Sprinkler system should be along the egress routes and not be restricted due to other considerations such as property damage. Non-water fire suppression systems such as gas cannot risk human life and must have additional controls, like for example a last out switch which prevents the gas from being released until the final person triggers it on the way out of the affected area. Communicate the emergency plans to all personnel and train them in execution of the plan. Next one is designing for protection. Other architectural, engineering, and local construction code concerns must meet local needs, such as facilities that are built to withstand and resist environmental hazards. The next one is continuity of operations. After we have seen to health and human safety concerns, our primary business focus should be continuity of critical operations. To begin with, we have to determine what the organization's critical operations are. In a cloud data center, that will usually be dictated by the customer contracts and SLAs. This simplifies delineation of those elements necessary to support critical needs. Business impact analysis can be of great use here, which informs us which assets could cause the greatest adverse impact if lost or interrupted. For instance, in a cloud data center, our main focus should be on connectivity, utilities, and processing capacity. These are therefore our critical operations. Other business functions such as marketing, sales, finance, HR, and so on might be wholly dismissed or greatly reduced without lasting impact to the organization and can be considered non-critical. In formulating this inventory of critical assets, it is important to consider all elements that support critical functions, not limited to the hardware and tangible assets, but also specific personnel, software libraries, documentation, fundamental data, and so forth, without which we cannot continue critical operations. The next topic is BCDR plan components. As with all plans, BCDR plan should be formalized in and derived from the organization's governance. Policy should dictate rules, terms of the plan, enforcement, and execution. The plan should include both a general, exhaustive, detailed description of all aspects of BCDR efforts and also limited, simple, straightforward procedures for enacting the plan and all response activities. Because the two categories of documentation differ so widely in content and purpose, they can often be included in the plan as appendices or attachments, and these can be referenced for the purpose of describing how and when each will be used. Let's discuss some of the items that should be included in the plan. The first is a list of the items from the asset inventory deemed critical. This should include necessary hardware, software, and media, including versioning data and applicable patches. This list should include all the important assets, data and processing, the current location of these assets, the networks between the assets and the sites of their processing, actual and potential location of workforce and business partners in relation to the disaster event. The circumstances under which an event or disaster is declared. Response comes with a cost. It is important to distinguish normal administration functions from event or disaster response because the formal response will obligate resources and affect productivity. Careful attention and explanation should be made for balancing the risks and benefits of overreaction and underreaction in terms of response. So, if you overreact and there are too many disasters frequently declared, then the productivity will needlessly be adversely affected. So, if you underreact and very rarely the disasters are declared, then the response activities may be hindered by delays for the sake of caution. Next one is who is authorized to make the declaration. An authority needs to be named for the purpose of formal declaration of an event or disaster. It can be an individual, a role, or office. We want to avoid the possibility of overreaction by allowing just anyone to initiate a formal response. And we want to ensure that initiation is instigated by someone who is informed, qualified, trained, and responsible for making such a determination. An authorized party must also formally declare the end of BCDR activity and resumption of normal operations. This should only be done when there is a high degree of assurance that all safety and health hazards have been removed and operating conditions and risks have returned to normal. Resuming standard operations can make the existing disaster worse or cause a new one. Essential points of contact. This should include the contact information of offices responsible for BCDR activity and tasks as well as any external activities that may be involved like regulators, law enforcement, corporate authorities, press, vendors, customers and so on. These should be as specific as possible to reduce difficulty in locating appropriate contacts during an actual response. The next one is detailed actions, tasks, and activities. Checklists can be quite helpful for BCDR procedures. Checklists serve several purposes. They describe the specific actions necessary. They can be aligned in order of execution and they can constitute a record after the activity is complete, what actions were taken by whom and when. Checklists also serve another fundamental requirement of BCDR plans used during a response action. They allow for someone to conduct the appropriate actions even if that person has not had specific training or experience with that plan in that organization. Of course, it is preferable to have the personnel assigned to BCDR roles trained and practiced in the specific plan, but especially during disaster or events, the assigned personnel are not always available. Always remember that updating BCDR policy will always be a continual process. BCDR terminologies. Recovery Point Objective RPO. The BCDR goal for limiting the loss of data from an unplanned event is RPO. Confusingly, this is often measured in time. For instance, if an organization is doing full backups every day and is affected by some sort of disaster, that organization's BCDR plan might include a goal of resuming critical operations at an alternate operating site with the last full backup, which would be an RPO of 24 hours. The recovery point objective for that organization would be the loss of no more than 1 day's worth of data. So another way of looking at RPO is to ask yourself, how much data can the company afford to lose? Recovery Time Objective RTO. RTO is the BCDR goal for recovery of operational capability after an interruption in service. That this is measured in time. This does not have to include full operations recovery. The capability can be limited to critical functions for the duration of the contingency event. Recovery Service Level RSL. RSL is a percentage measurement of how much computing power is necessary based on the percentage of the production system needed during a disaster. If all services will be restored during a disaster, then it has 100% RSL. But if only the most critical services will be restored during a disaster, then it might have like 30% or 40%, something like that, depends on the organization of RSL. RPO, RTO, RSL are completely dependent on organizational requirements. Remember that business impact analysis BIA determines the RPO, RTO, right? The next one is maximum allowable downtime. How long it would take for an interruption in service to kill an organization. This is measured in time. For instance, if a company would fail because it had to halt operations for a week, then its MAD is 1 week. This is also sometimes referred to as maximum tolerable downtime MTD. Related to maximum allowable downtime is the mean time to repair MTTR, which is the average amount of time it takes to repair a damaged system or device that is down. Annual loss expectancy ALE. This describes the amount an organization should expect to lose on an annual basis due to any one type of incident. ALE is calculated as shown on the screen, that is ARO into SLE. ARO is the annual rate of occurrence and SLE is the single loss expectancy. The annual rate of occurrence is the rate of occurrence of a specific event or security event one could expect in any given 12-month period. A single loss expectancy SLE is the amount of expected damage or loss from any single specific security incident. BCDR strategy. The key for the cloud security professional is to understand how BCDR can differ in a cloud environment from the traditional approaches that exist in non-cloud environments. Some of the questions that need to be answered before an optimal cloud BCDR strategy can be: is the data sufficiently valuable for additional BCDR strategies? What is the required RPO, that is recovery point objective, that is what data loss would be tolerable? What is the required RTO, that is what unavailability of business functionality is tolerable? What kinds of disasters are included in the analysis? Does that include provider failure? What is the necessary RSL for the systems covered by the plan, etc., right? We have different components as well that need to be considered when we are talking about BCDR strategy. Let's discuss a few of them here. For example, location. As each BCDR strategy addresses the loss of important assets, replication of those assets across multiple locations is more or less assumed. Power or network failure may be mitigated in a different zone in the same data center. Flooding, fire, and earthquakes likely require locations that are more remote. Switching to a different cloud service provider will also likely affect these sites of operations. This is unique to the cloud model because traditional IT solutions do not readily lend themselves to contemplating a switch to a different provider. The use of Memorandum of Understanding along with SLAs to regulate and guide a switch should be thought out ahead of time and put in place prior to a switch taking place. Geographically separating resources for the purpose of BCDR can result in a reduction of, say, flooding or earthquake risk. Counterbalancing this is the fact that every cloud service provider is subject to local laws and regulations based on geographic location. And we should also be able to answer the question, can the remote site handle the cutover? That is, do we have adequate bandwidth and services? One is data replication. Data replication is about maintaining an up-to-date copy of the required data on a different location. It can be done on a number of technical levels and with different granularity. For example, data can be replicated at the block level, file level, database level. Replication can be in bulk on the byte level, file synchronization, data mirroring, daily copies, and so on. These alternatives can differ in the RPOs, recovery options, bandwidth requirements, and failover strategies. Each of these levels allows the mitigation of certain risks, but not all risks. For example, block level data replication protects against physical data loss, but not against database corruption. Also, it does not necessarily permit recovery to a different software solution that requires different data formats. Furthermore, backup and archive are traditionally used for snapshot functionality, which can mitigate risks related to accidental file deletion and database corruption. Beyond replication, there may exist an opportunity to re-architect the application so that relevant data sets are moved to a different provider. This modularizes the application and makes the data more resilient in the face of a power failure. Examples of components to split off include database as a service and remote storage of log files. In contrast with infrastructure as a service, PaaS and SaaS service models often have data replication implicit in their services. However, that does not protect against failure of the service provider, and exports of the important data to external locations may still be necessary. In all cases, selecting the proper data replication strategy requires consideration of storage and bandwidth requirements. The next one is functionality replication. Functionality replication is about recreating the process's capacity on a different location. Depending on the risk to be mitigated and the scenario chosen, this could be as simple as selecting an additional deployment zone or as involved as performing an extensive re-architecting. In the SaaS case, this replication of functionality might even involve selecting a new provider with a different offering, implying a substantial impact on the users of the service. Examples of simple cases are a business that already have a heavily virtualized workload. The relevant VM images can then simply be copied to the cloud service provider, where they would be ready for service restoration on demand. A modern infrastructure cloud service customer is likely to have the application architecture described and managed in an orchestration tool or other cloud infrastructure management system. With these, replicating the functionality can be a simple activity. Functionality replication timing can be across a wide spectrum. The worst recovery elapsed time is probably when functionality is replicated only when disaster strikes. A little better is the active passive form where resources are held standby. In active mode, the replicated resources are participating in production. The active mode approach is likely to demonstrate the most resilience. One is failover capability. The failover capability itself requires some form of load balancer to redirect user service requests to the appropriate services. This capability can take the technical form of cluster managers, load balancer devices, or domain name system DNS manipulation. It is important to consider the risks that these components introduce because they might become a new single point of failure. Returning to normal. Return to normal is where DR ends. In case of a temporary failure, the return to normal would be back to the original provider or in-house infrastructure. Alternatively, the original provider may no longer be a viable option, in which case the DR provider becomes the new normal. In all cases, it is wise to adequately document any lessons learned and clean up any resources that are no longer needed, including sensitive data. The whole BCDR process, and in particular the failover event, represents a risk mitigation strategy. Practicing it in whole or part strengthens the confidence in this strategy. At the same time, such a trial run can result in a risk to production. These opposing outcomes should be carefully balanced when developing the BCDR strategy. And also, if the failback strategy is not tested well, a failback can worsen the existing disaster or create a new one. BCDR plan. The creation and implementation of a fully tested BCDR plan that is ready for the failover event has a great structural resemblance to any other IT implementation plan as well as other disaster response plans. It is wise to consult or even adapt existing IT project planning and risk management methodologies. When organizations are incorporating IT systems and cloud solutions on an ongoing basis, creating and re-evaluating BCDR plans should be a defined and documented process. The first step is the scope of the BCDR plan. The BCDR plan and its implementation are embedded in an information security strategy, which consists clearly defined roles, risk assessment, classification, policy awareness, and training. It makes sense to consider BCDR as an intrinsic part of the IT service that is regularly invoked, if only for testing purposes. One is business requirement analysis. We need information in order to conduct security activities in a proper and efficient manner. There are certain things we need to know in order to decide how we will handle risks within our organizations. We will discuss a few of them here. The first one is inventory of assets. To protect our assets, we first have to know what they are. Everything owned or controlled by the organization can be considered an asset, and assets take many different forms. Assets can be tangible, such as IT hardware, retail inventory, buildings, vehicles, etc. Assets can also be intangible, such as intellectual property, public perception, and goodwill with business partners and vendors. Personnel can also be considered assets because of the skills, training, and productivity they provide to the organization. In order to protect all our assets, we have to know what they are, where they are, and what they do. If we lose track of something under our control, it becomes impossible to secure that thing. Therefore, the first step in creating a good security program would be to perform a thorough, comprehensive inventory. There are many methods and tools for doing so, such as surveys, interviews, audits, etc. In performing an IT inventory, we can also incorporate automation into the process, enhancing our capabilities and efficiency. The next one is valuation of assets. While we know the number, location, and type of assets, we also want to determine the value of each. We need to be able to know which of the assets provide the intrinsic value of our organization and which supports this value. This is a process known as business impact analysis, BIA. This is the process known as business impact analysis, BIA. We determine a value for every asset, usually in terms of money, but sometimes according to priority or rank, customer perception, or other measures. What it would cost the organization if we lost that asset, either temporarily or permanently. What it would cost to replace or repair that asset, and any alternate methods for dealing with that loss. There are various ways to assign cost. We can use the insured value, the replacement cost, or some other method of making that valuation. Usually, we allow the data owners, that is, the individual line of business managers responsible for their respective data, to determine the value of the information under their control. There are some risks associated with letting the data owners assign value to their assets. The most significant of those is the tendency of data owners to overvalue assets that belong to them. The data owner is also tasked with assigning a category and classification to their data, usually when it is created. The next one is determination of criticality. Once the inventory and valuation is complete, the BIA effort continues with a determination made by senior management regarding criticality. Criticality denotes those aspects of the organization without which the organization could not operate or exist. These could include tangible assets, intangible assets, specific business processes, data paths, or even essential personnel. Senior management has the proper perspective for making determinations of criticality. The security professional, however, should have a good understanding of the overall mission and function of the organization in order to better serve and advise the organization in securing critical elements. Another function of the BIA process that can support the security effort is the identification of single point of failures. If there is any choke point in a process, procedure, or production chain, a place where an entire workflow would halt because of the loss of a single element, that is a single point of failure. Single points of failure, especially in critical paths, pose a significant risk to organization and have to be addressed as soon as they are identified. Like critical aspects, single points of failure can be caused by hardware, software, processes, or personnel. Some of the methods to deal with single points of failure are adding redundancies, creating alternative processes, cross-training personnel, consistently and thoroughly backing up data, load sharing or balancing for the IT assets. Risk appetite is the level, amount, or type of risk that the organization finds acceptable. This varies widely from organization to organization based on innumerable factors, both internal and external, and can change over time. Risk is the likelihood an impact will be realized. Risk can be reduced but never be eliminated. Organizations accept a level of risk that allows operations to continue in a successful manner. It is legal and defensible to accept risk higher than the norm or greater than your competitors. Accept risks to health and human safety. These risks must be addressed to the industry standard or the regulatory scheme to which your organization adheres. Organizations have four main methods to address risk: avoidance, acceptance, transference, and mitigation. Avoidance. This isn't really a method for handling risk. It means leaving a business opportunity because the risk is simply too high and cannot be compensated for with adequate control mechanisms. A risk that exceeds the organization's appetite. Acceptance. The opposite of avoidance. The risk falls within the organization's risk appetite. So the organization continues operations without any additional efforts regarding the risk. Transference. The organization pays someone else to accept the risk at a lower cost than the potential impact that would result from the risk being realized. This is usually in the form of insurance. This type of risk is often associated with things that have a low probability of occurring but a high impact should they occur. Mitigation. The organization takes steps to decrease the likelihood or impact of the risk. This can take the form of controls or countermeasures and is usually where security practitioners are involved. Risk is involved in every activity. We can manage risk, attenuate it, even minimize it, but there is always an element of risk in operations. When we choose to mitigate risk by applying countermeasures and controls, the remaining, that is the leftover risk, is called residual risk. The task of the security program is to reduce residual risk until it falls under the acceptable level of risk according to the organization's risk appetite. The risk appetite of an organization is set by senior management and is the guide for all risk management activities in the organization. The security professional must have a thorough understanding of the risk appetite of the organization in order to perform their functions properly and efficiently. Next step is analysis of the plan. The purpose of the analysis phase is to translate BCDR requirements into input to be used in the design phase. The most important inputs for the design phase are scope, requirements, budget, and performance objectives. Business requirements and the threat model should be analyzed for completeness and consistency and then translated into an identification of the assets at risk. We should consider identifying all dependencies, including processes, applications, business partners, and third-party service providers. For example, what are the technical components and underlying services of an application operated in-house that need to be replicated in a BCDR facility? Analysis should identify any opportunities for decoupling systems and services and breaking any common failure modes. Capabilities of the current providers in delivering resources to the BCDR solution should be investigated. Performance requirements such as bandwidth and offsite storage needs derived from the assets at risk. Careful analysis and assessment should be undertaken with the objective of minimizing these performance requirements. Risk assessment. In the same way as any IT solution should be assessed for residual risk, BCDR solution should be assessed for residual risk. All scenarios involve evaluation of the cloud service provider's capability to deliver. Some of the typical challenges involved in this process are the elasticity of the cloud service provider. That is, can the cloud service provider provide all the resources if BCDR is invoked? Contractual issues. Will any new cloud service provider address all contractual issues and SLA requirements? Available network bandwidth for timely replication of data. Available bandwidth between the impacted user base and the BCDR locations. Legal and licensing risk. There may be legal or licensing constraints that prohibit the data or functionality to be present at the backup location. The next one is plan design. The objective of the design phase is to establish and evaluate candidate architecture solutions. This design phase should not just result in technical alternatives but also flesh out procedures and workflow. As with any IT service or system, the BCDR solution should have a clear owner who is accountable for the correct step up and maintenance of the BCDR capability. That is a clear role and mandate in the organization. So we have to define technical owners who declares the BCDR event, who is the owner for communications to customers, internal communications, who are the decision makers, etc. Some of the additional BCDR specific questions that should be addressed in design phase are: how will the BCDR solution be invoked? What is the manual or automated procedure for invoking the failover services? How will the business use the service be affected during the failover? The next one is planning, exercising, assessing, and maintaining the plan. Once the plan has been completed and the recovery strategies have been fully implemented, it is important to test all parts of the plan to validate that it would work in a real event. The testing strategy should include expectations for business lines and support functions to demonstrate the achievement of business continuity test objectives consistent with the business impact analysis and risk assessment. It should also include a description of the depth and breadth of testing to be accomplished. It also includes the involvement of staff, technology, and facilities, expectations for testing internal and external interdependencies. It also includes an evaluation of the reasonableness of assumptions used in developing the testing strategy. Testing objectives should start simple and gradually increase in complexity and scope. Some of the things at a minimum that are accomplished by the testing scope and objectives are: ensure support for normal business operations, gradually increase the complexity level of participation, functions, and physical locations involved, demonstrate a variety of management and response proficiencies under simulated crisis conditions, progressively involving more resources and participants, uncover inadequacies so that testing procedures can be revised. Consider deviating from the test script to interject unplanned events such as the loss of key individuals or services. Involve a sufficient volume of all types of transactions to ensure adequate capacity and functionality of the recovery facility. Test plans should clearly communicate the predefined test scope and objectives and give participants relevant information such as a master test schedule that consists of all test objectives, specific descriptions of test objectives and methods, roles and responsibilities for all test participants, including support staff, designation of test participants, test decision makers and succession plans, test locations, test escalation conditions, and test contact information. BCDR testing should be done at least annually. Tabletop exercise. A tabletop exercise is a formal walkthrough of the BCDR plan by representatives of each business unit involved in BCDR activities. The walkthrough includes reviewing the plan itself, discussing each step in the process, and clarifying roles, responsibilities, and any open questions from stakeholders. As the simplest BCDR testing method, this method is not preferred for actual testing, but it is better suited as a training exercise to get all stakeholders on the same page. The next one is walkthrough drill or simulation exercise. A simulation exercise is an enhanced version of a tabletop exercise that leverages a predefined scenario. Participants again walk through these steps in the BCDR, this time adding specific actions that should be followed during the imaginary scenario. These exercises generally involve some form of simulated notifications and mobilization activities, but stops short of actual physical mobilization to alternate sides. Parallel test. A parallel test takes things to the next level and involves bringing the secondary side to full operational capacity while maintaining all operations in the primary site. Staff is mobilized to the alternate site along with any equipment and resources they would bring during an actual event. This test is essentially a full drill that stops just shy of shutting off the primary infrastructure. The next one is full-scale test or full interruption test. The entire organization takes part in an unscheduled, unannounced practice scenario performing their full BCDR activities. As this could include system failover and facility evacuation, this test is the most useful for detecting shortcomings in the plan, but it has the greatest impact on productivity to the extent it can cause a full genuine interruption of service. Regardless of the testing method selected, once testing is complete, a comprehensive report must be generated and published for all stakeholders to review the testing results, including what worked, what did not work, and any lessons learned. The report should include action items based on the lessons learned, with each action item being assigned an owner and tracked through completion. This report should serve as an input to revise the BCDR plan and the next BCDR test exercise. This is the end of today's video and it is also the end of chapter 3. I will see you in the next video. Until then, take care of yourselves. Bye bye.